Good morning, everybody. Today is Tuesday, October 11th, 2022. I am, waiting to watch the Phillies game at 1 o'clock. And today we're going to be working on some more Elixir Exercism track stuff. And today we're going to be talking about streams. So let's click right on into the concept documentation. All functions in the enum module are eager. When performing multiple operations on enumerables with the enum module, each operation is going to generate an intermediate result. The stream module is a lazy alternative to the eager enum module. It offers many of the same functions as enum, but instead of generating intermediate results, it builds a series of computations that are only executed once the stream is passed to a function from the enum module. Streams implement the enumerable protocol and are composable. You can chain them together to create more complex functionality. So this is this is one of the really cool features of Elixir. So the general problem is that sometimes you're dealing with particularly large data sets. And so you start off at the top and you've got this extremely large data set or source, like a file or something. And you want to process it, and you're going to process it in a series of steps. When you're starting out, it's really nice and simple to use the enum module because it lets you kind of like introspect through like inspect statements and stuff, like each step of the way, and kind of see like how the transform is going through step 1, step 2, step 3, and so forth. But it's kind of inefficient, and so streams offer a way to make these transformations extremely efficient and consume much less memory, be much faster, with the kind of con that it's a little bit harder to debug, but you'll get better with it over time. I personally view streams to do things like CVS parsing. So let's say you've got some really big CSV file and you want to import it. Rather than importing the entire file into memory, you kind of open the file as a stream and then you can process it that way, and you get really nice, fast, and memory efficient processing, which is really cool. All right, cool. So today we're going to be working on the Lucas numbers example. You are a huge fan of the number file YouTube channel, and you just saw a cool video about the Lucas number sequence. I what that is. You want to create the sequence using Elixir. When designing your function, you want to make use of lazy evaluation so that you can generate as many numbers as you want, but only if you need to. So you decide to use a stream. Okay. I'm wondering how much they expect me to know what this thing is, but we'll just get started for now. You may have to come back and watch that YouTube video, which seems a little weird. We'll check it out. So we're going to CD into that. We're going to open this up in VS Code. And just like we always do, we're going to open up the source file and the test file and the README file. And we'll hide the source list. And just for kicks, we'll run all the tests in the text explorer, so we see a lot of red X's on our tests. Is this a place to start? Okay, so number 1. Okay, so here, Lucas numbers are an infinite sequence of numbers which build progressively, which hold a strong correlation to the golden ratio. I have no idea what that means. Golden ratio. E.g. 2, 1, 3, 4, 7, 11, 18, 29. Oh no. I have no idea what that is. You know that the sequence has 2 starting numbers which don't follow the same rule. Write 2 base case clauses to return these numbers. Okay. Let's do this in a very like test-driven development oriented way. Actually, instead of case, well, they say write 2 base Case clauses. Yeah, they want us to use case. I was gonna do it as a pattern map. I'll follow the instructions and do it as case. So when they pass in one, or no, when they count, when count is one, we're gonna return a list with the integer 2, and then when count is 2, we're gonna return to 1. And then if case doesn't match, then it'll throw an exception. Okay, let's run all the tests in the test explorer. See some stuff pass, hopefully. Okay, that task one passed, so now we're up to task 2. Create the generalized sequence for any sequence longer than 2. So like the argument coming in is the count. So when they pass in 1, you get a single element, but when you pass in 2, you get 2 elements. Okay. For any sequence longer than 2, you know that you need to add the previous 2 numbers to get the next number, and so on. Write the generalized case. So okay. So when 3 comes in, we expect a list of 2, 1, 3. And then when 4 comes in, we expect 2, 1, 3, 4. So the new element is through the addition of the previous 2 in the sequence. Okay. Okay. uh Generate sequence of 5. So the whole idea here is that we're supposed to be solving this with stream, right? Yeah. But they're not. How do they? It's non-integer argument. It's kind of weird. While completing this lookalike, you will learn one new concept: stream. I have to solve this with stream. I mean, all right. This just seems like an exotic number problem. I mean, you can solve it with streams, I'm sure, but I wish it was more solid into it. But okay. So how do we do this? How do we do this? Let's open up the document for the stream module. Because like we're gonna have a range, you don't map this range, this function, this sequence. I mean that's kind of where we're headed. We're gonna have a range. It's gonna start off as 1. So let's do that. Let's just start off with you're gonna have range, and it's gonna be 1 dot dot count. And so if you do IEX, so if you were to do 1 dot dot 1, would be 1 element, right? Let me try this one. Then okay, So 1 dot dot 1 only gets mapped as a single element to the result. Makes sense. Um, so the enum way to do this is enum.map, and that would accept the range, and then it gets an anonymous function. Um, I'm gonna solve this with like find p, and this is going to be um, number generate. Um, let's call it dude. I don't know. Um, so I don't think you can use map because you kind of need an accumulator. Well, you could do. Why doesn't it list the? I'm looking to see if they module. What? Um, transform an existing stream. Yeah, this is like kind of what we want. It expects an accumulator and a function that receives 2 arguments. Uh, Note this function is equivalent to flat map reduce return once the stream is processed. It maps and reduces an enumerable, flattening the given only one level. Uh, I don't know. I'm not gonna worry about the stream solution for now. I just want to solve the regulars. Um, so how do I want to do this? We'll call this Lucas get Lucas sequence. Uh, I mean, basically, what you want to do is you say like, given like the current sequence, you know, um, get like next Lucas number, you know. So like given account, so like, but like given given a list of like 1 2 3, um, or 2 1 3 or 2 1, you would expect to return 1 3. So we need to get the last 2 elements from the list. It's really unfortunate because um that would require you to go to the end of the list, and that's like kind of against the way linked list works in Elixir. So we'd almost want to do this like backwards, um, and then just reverse it at the end. So like you'd start it off as like it would start off as empty, and then it would be 2, and then it would be 1 2, and then like you'd return it as the reverse of that. But then like internally it would be 3 1 2, and then you'd return it as 3. So like as we're building it up, we'll build it up one direction to make it easier. And yeah, that should be so. So this can be a thing where like when is list current. I'll just call it sequence. Current is kind of redundant at that point. When it is a list and when the length of that list is guaranteed to be, I spell it right, is greater than or equal to 2, then we can do our thing. And so the list module, we can see things like this, like first pop at um I mean, I want the first 2 things. Key find. No, because this isn't going to be keyword last. Ha. With. Zip. I mean, I think you can use the access stuff, right? Yeah, at index. Returns a function that accesses the element given get. Yeah, list does not implement the access behavior. Yeah, keyword list would, but not a regular. Okay. So we'll just get it with deconstruction. So like if we deconstruct this as like first, tail, sequence, and then second tail. So that would be like, and then the next number would just be first plus second, and it wouldn't get the. Maybe this is like where we actually do the case. So like, no, this is next given a sequence. So given the current sequence, what's the next number? So this would be like p get next this number sequence. This is going to be when it's an list, and it's an empty list. The next number is going to be a 2. and when next is number, and when the list is just a 2, the next number is going to be a 1. And then otherwise, it'll do this thing. I'll just. Okay. And so this thing, starting with a range of 1 dot this, we need to enum dot map. No, we don't want to. It's more like reduce, right? Invokes function for each element enumerable with an accumulator. Yeah, it's more like reduce. So we're going to reduce the range, and we'll just do it like this. And the accumulator is going to be an empty list, and then I. That. So enum reduce one dot count. It's going to start off as an empty list, and we're going to get I. And so what we'll do is we're going to say get. We're going to get the next Lucas number. We're going to pass it I, or no. No, we need to accept. We're using enum. We're going to need the one with the accumulator, so we're going to pass it. The accumulator is the second of that. So this is going to be I, and that's going to be the accumulator. And so we'll say next number. We'll get the next Lucas number by passing in the accumulator. And then reversed list. We'll capture the list up there because we're going to need to reverse it down here. List dot reverse, flip, flatten, fold. What is it? Last, pop, replace. Crap, I'm missing. Reverse? String reverse? Enum reverse. Okay. Enum reverse. And list. Okay, so we'll get the next number, and then we need to list dot no. So when you run this reduce, it needs to return the accumulator. So we want to say accumulator plus plus, because we're gonna put it. No, we're gonna put it in the front because we always next number. About eyes on you. Guess we're not using it. Because we're just doing that number of times. Tail is uncapture that there. I'm gonna run the test just to see what happens here. Are they all passing? They're almost all passing. Okay. So let's see here. Generate the generalized case. I think that's working. Task 2 is all working, right? Yeah. Okay, wow. So we're gonna have to come back and stream this up. We're not solving it with streams yet. Um, but we'll finish working on it. Correct. Catch incorrect non-integer arguments. Assert raise argument error. Count must be specified as an integer. Later, you find someone who's using a function having problems because they're using incorrect arguments. Add guard clause, raise an error if non-integer or an integer less than one is okay. So we can say when is integer count and count is greater than one. Maybe on all tests. No. Run at cursor. This. Let's try that one more time. Run at cursor. Non-integer arguments. Expected argument error. Got function clause error. Count must be specified as an integer greater than. Expected argument error. Got function clause error. They don't expect to generate errors. Count must be specified as an integer greater than or equal to 1. Like, that is a very error. I mean, you could. I mean, you think of it, this is like you could check it there. Okay, well, something. Are any of these passing? So, like, when they pass hello world, it's not failing. Like, and when they pass a negative integer, and when they pass a negative integer, they get function clause error argument. I mean, so like what they're getting is function clause error because there's no function that matches this. It's trying to call generate and it's using this guard statement, and it's not finding it because it's looking for another function called generate that doesn't have this guard clause. That's not happening, and so that's why you get function clause error. To do an argument error, I assume you'd have to like just do it, and then you do the check inside and raise. That's not a pattern that I'm used to. Later, you find someone is using your function and having problems because they are using incorrect arguments. Add guard clauses to raise an error if a non-integer. Add guard. I mean, is there a way you can customize the error of a guard clause? Guards are away. In guards, when functions would normally raise exceptions, they cause guards to fail. In guards, when functions cause the guard to fail instead, for size function only works with tuples if we use anything else. An argument error is, however, when used in guards, the corresponding clause will to match instead of the raising. However, if your guard is multiple condition. Uh, Only constructs listed in this page are allowed. However, I'm looking. While it's possible to create custom guards and compile, check. So I mean, they're looking for this very explicit argument. I'm not sure how they never really. I mean, we learned errors. Like if we go back to the syllabus, and you'll see like we, yeah, we learned errors to get to streams. So like they know we're supposed to know uh how to do that. And specifically we didn't have to learn exceptions to learn to do this one though. So it's not like we've built our own thing. Anyway. Let me Elixir. Uh no. Search. I mean, here's the thing. Like, I could totally do a thing where, like, I don't do it like here. I do it instead. I do it inside the function, and like if I see that it's not an integer, I raise, and if I see it's not a count greater than one, I raise. But the reason I don't want to do that is because they've explicitly told me to solve this with a guard, and I'm not sure why a guard clause would throw an argument. Let me try. I'm going to remove this for a sec. Save that. Let me run this at cursor. Test catch incorrect non-integer arguments. Wrong message for argument error. Count must be specified actual. Yeah. So, all right. I'm gonna do this in here, which seems so dumb. I don't think you'd want to do it as a case, right? I'm gonna do this the stupidest way. If unless oh geez, this is looking awful. Unless is integer. Yeah, spell it integer, right? Count raise argument error. A comma. With the message. Count must be. Well, you could do it, and you could do count greater than count must be specified as an int greater than or equal to greater than. This. That's frustrating because like this is not a guard statement. Um, I guess you can write your own guard statement. Maybe that's what they're trying to have us do. I don't think guard. Kernel. Find guard. Generates a macro suitable for use in guard. It raises compile time if the definition expressions. Oh yeah, we should be able to do that. Is even. All right, let's do it like that. Let's say define guard is valid, and then oh well, no, it's just that's just using the when there. You're not actually putting a custom function. Maybe that's not. All right, I'm gonna. You know what we're gonna do? We're gonna go for this. So like, if I run all the tests, everything's passing now, and so what I think I'm gonna do is I'm gonna take a peek at the functions, the solutions that they have provided. So let me just clean this up a little bit for now. And let's submit it with enum, and let's see if the analyzer yells at me for not using stream, because that's the whole point of this lesson. Exercism submit lib Lucas numbers. Using blank instead of blank is longer and less. List. Okay, do that. So simulator, fine. Well, let's resubmit it and see if passed with no problems. Okay. Let's see how they solved this. Generate when is. Yeah, they're using. Oh wait, generate do. Oh, that's how they solve. So they're using pattern matching and guard statements to capture this so that it only runs here. And then they do a fallback function to raise the argument error. I see. All right, that makes sense. So we'll do that as well. So we can get rid of this, and we'll re-add our stuff. It's greater than or equal to 1, and that'll work. And then what we need to do is we should fix this as a stream. So so if you're normally using use, then you should use stream dot what cat cycle. It's a stream that cycles through the given infinite. Interesting. Creates a stream that only emits elements that are different from the last emitter. All right. Maybe each. Stream.each. Given executes the given function for each element. kind of what we want, but doesn't have accumulate. Map to form. That has an accumulator, so it transforms an existing stream. Um, you can do this list to stream. Enum. What am I looking? I'm looking for a way to make a stream. Yeah, I'm finding the concept docs for this to be a little light. Um, uh, once you, I mean, the range is going to be like an abstract concept. Um, let's see. String. I could peek at the solutions that the community have. Feel like I'd rather figure it out on my own. Okay, so stream starts equals 1.3 stream.map. Okay, so you can just pass in a range to these, and that should be fine. I think I want transform because it has an accumulator. Transforms an existing stream and expects an accumulator and a function that receives 2 arguments to the stream. So like, I think I want it like this. Like, it starts off as 1.count, and then it goes stream.transform, and first time the enumerable, then the accumulator, which starts off dlist, and then the function, which is the reducer. So the function takes element in the accumulator, so underscore accumulator, and then end. And we can probably just simplify this as like get next number and accumulator. And then pretty sure there's not a stream dot reduce or reverse. So we'll just do enum dot reverse. And that'll be fine. Does all this stuff still pass? Next test. Clause 2. No case closing match 2. Where did I break? Let me run all the tests up here. Explore, run all tests. They're all failing. Oh my god. So we'll run a cursor. Generates a sequence of length 1. Sure it is. There. Get next Lucas number. Um. It could be that transforms an existing stream. It expects an accumulator and a function that receives 2 arguments. The stream element and the updated accumulator. It must return a tuple where the first element is a new stream, often a list, or the atom halt, and the second element is the accumulator to be used by the next element. Oh. Um. The first element is a new stream. Uh. Trying to figure out what by return a tuple where the first element is a new stream, often a list. Um. Off list. All right. Well, first off, I'm going to pull this. Because we solved for the sequence. In a reverse order to reverse it before the final return. And then I'll wrap. And then this thing. Gonna be its own line. But that's not. So this needs. The second element is the element new string. One dot dot count. A dot dot. And that's fail. Generate a test sequence with 1. It expected 2. This is annoying. I don't like this. And a lot of the exorcism puzzles, like exercises, are very puzzly like that. That's not good at or. And it's frustrating because the whole concept is about streams, and it's like we solved it without streams. There's no obvious benefit. It really should have attached the learning exercise should have attached some like relevant data sets so that way it was very clear to the benefits of using streams. And like you could almost like evaluate it like more than like 1 second to pass. That would help people working through this with like an enum solution. But all right, is there anything else besides transform that might be a good solution for this? Map. That's not. I can't use map. I need an accumulator. Uh. I think I want transform. I just don't understand the return type. Flat map reduce. Maps and reduces an enumerable, flattening the given result in one. Expects an accumulator and a function that receives each enumerable element. A new enumerable. Often a list or called. All right, I'm gonna peek any solutions. This is taking. Unfold. Unfold 2-1. Function xy. What is this? Unfold. So generate count. Take count. Enum.take count. Wow, what the hell is enum.take? Takes an amount of elements from the beginning or end of it. Positive amount is given. The amount. So what are they doing here? So they're creating a stream, like an indefinite stream, like like this is a. I mean, this is a good kind of theoretical solution because like you're creating this indefinite stream, and you're just starting it off with 2 and 1. That's the initial value, and then that's a really abstract thing. Iterate. Starting as a tuple. Uh, -1. I have no clue. I mean, stream.iterate. What is stream? Iterate. Emits a sequence of values starting with the start value. Successive values are generated by calling next function. I mean, like, this makes sense, but like, real frustrating thing is like if I'm learning on Exercism, like I am not familiar with this iterate functions. Like you need to like in the concept doc, you kind of need to like hint me towards like these are the functions that are available to you. You may want to use. I mean that makes sense. Like okay, I'm going to start off with a tuple, and it's going to generate the sequence like that. I can see that as a solution. Like that makes sense. Um, and then they map, and they do take -1. Wow, that is just like, I mean, these are really obscure solutions. A lot of them are iterate. It is integer golden. Oh, yeah, I had no idea what that was. That was part of the readme too, right? Like, um, where did we see that? Misrem, miss. Uh, I don't know. I don't know what I want to go with. Unfold. How do they describe unfold? Emits a sequence of values for the given accumulator. Successive values are generated by calling next function with the previous accumulator, and it must return a tuple with the current value and the next accumulator. The enumeration finish if it returns null. Okay, so stream.unfold. So if you start with the integer 5, then you get this function. So 5 will get passed in. 5 will return the value 5, and then n-1, which will keep calling itself until you get to 0, and nil will get passed in. It's done to a list. I mean, that sounds pretty close to what we want. So they start with unfold with a tuple of 2 and 1. And then they call a function that returns a tuple with, so they're just building it up like x, and then this new value, which will be y plus y. I mean, the one thing I don't like about this is like it's building the indefinite. So like you're getting these repeats of values. Well, not really. Um, I don't know. I think I'm gonna just finish this up. So let's I mean, the one benefit of this is too is that we don't have to do the reverse thing. Um, see, I don't like piping with that like awkwardness. I don't know. So it starts as 2-1, and then it'll unfold it. So 2-1 will come in, then the return value is, it's basically this like tuples inside of tuples inside of tuples. So then the return value here is x, comma, and then the inner tuple is y, And then it's x plus y, which that makes sense. It's not clear to me how this knows to end. It doesn't. I guess that's the whole point. The stream never ends. It's this abstract concept. It only gets evaluated when you call enum.take. So you pass this, stream. Actually, I'm going to call it stream here, sequence stream. So only when you pass sequence stream to enum is it actually evaluated, and then turns the count, which is probably a fair solution. And so with that, we don't need any of this anymore because we never called it. So we just got that. Let's see. Mix.test. They all pass. Okay. So let's submit this. So this is kind of this is an interesting solution. Like this session took a long time, but I actually like the progression of the fact that like we solved it with enum, and then then we work backwards to sign stream. Although I still wish there were the example was exercised a little bit more. I don't know. I wish it was different in that it made it more clear as to like the reason you want to use stream is because you want to do something quick with like low memory. We're not doing any of that testing, so that looks a little weird. But anyway, I learned a lot today. And so we'll publish our iterations and we'll mark this as done. And we'll show more concepts. And yeah, so we've mastered streams. Cool. So next time it looks like we're going to be talking about behaviors. And when that happens, I hope you join me. Hopefully you learned something today. Thanks a lot for watching. If you have any questions or feedback, please do let me know. Other than that, have a great day, and I'll see you next time. Bye-bye.